Okay, so we're going to make another subclass. We're actually going to make a subclass of Rainbow Bug, but one useful thing that we're going to want when we do that is we're going to want Rainbow Bug to have a constructor that allows outside elements to create rainbow bugs by putting in their own array of color objects. Since an array of colors is an instance variable, outsiders should be able to initialize that array with their own values. So I've gone ahead and written another constructor for Rainbow Bug. This one takes an array of colors as a parameter. Again, notice it starts out by calling super, which simply executes the noargs constructor in the bug class. Possible colors is the instance variable that we have here. It's being initialized as a new array of colors, the same length as input colors. And then I have an ordinary for loop that goes through the input colors, that's the parameter array, and copies the input colors value in index into the instance variable location at index. So we have this constructor available to us. Alright, so what we want to do now is we're going to go create a subclass of Rainbow Bug. We do this the same way. We're going to call this Methodical Rainbow Bug. So Methodical Rainbow Bug, we want it to be a subclass of Rainbow Bug. So we write, and that seems to work. So I've provided the method signature for a constructor for Methodical Rainbow Bug, so it can accept an array of colors as a parameter. And so what we want to do here in the very first line of this constructor is simply to call super pass colors up into the superclass constructor that anticipates an array of color objects. So basically it's going to execute the Rainbow Bug constructor that anticipates an array of colors. This is the one I just showed you, right? The one I wrote secretly. So this is the constructor that's going to execute. When that happens, notice it is going to go execute the constructor in bug. So you're going to have this chain reaction of constructors going up the inheritance hierarchy. The possible colors array will be initialized up here in Rainbow Bug. Also, this is a good time to point out the fact that remember when we defined that this array was protected instead of private. Remember that protected means that subclasses are allowed to access this value directly. That means that Methodical Rainbow Bug, our subclass of Rainbow Bug, can use this directly without using a get method. It's as if it's public to subclasses but private to everyone else. So that's the advantage of having a protected instance variable. Alright, so here I am, I've written my constructor, and the idea of Methodical Rainbow Bug is this: we're just not going to pick a random color, we're going to iterate through our array methodically, one step at a time. So we should have an instance variable that keeps track of what index we are currently on. So I'm going to create this current index instance variable, and I ought to initialize that in the constructor. So we'll start current index out at 0, and it's going to increment every single time the act method is called. So when the act method is called, we want current index to increment, and we want the color to be chosen slightly differently, but this does mean we need to override the act method. Again, remember that when you define a method in a subclass that already exists in the superclass, we say that we are overriding that method. So the act method in Methodical Rainbow Bug is overriding the one that would otherwise be inherited from Rainbow Bug. However, we do want all of Rainbow Bug's code for free, right? We don't want to redo all of that work, so we're going to write super.act, and that one little line of code is going to execute all of the code up in Rainbow Bug. And then what we do want is for current index to ++. Now, did we really get everything done that we needed to get done? No. There's a little bit of complexity here that I want to point out. And current index isn't really being used up in the superclass, and the super.act method is going to randomly choose a color for Methodical Rainbow Bug, and we don't want it to do that. So what we're going to do is we're actually going to go up and we're going to redefine Rainbow Bug. What we're going to do is we're going to take the code that randomly chooses an index out of the act method and put it in a separate helper method. That way we can override that method in Methodical Rainbow Bug and take out the random element. So let's go back up into Rainbow Bug and you'll see what I'm talking about. So notice, Rainbow Bug chooses its index randomly. Since it's part of the act method, we either have to override all of this code or none of it at all. And that's not really what we want. So what we're going to do in order to help our subclass out a little bit is we're going to create a little helper method. So we're going to write a little method called chooseIndex. And this method is going to do the random stuff. I'm going to take this code, I'm going to cut it, and I'm going to do it here, right? So I'm going to return the number 1 plus a random number, blah, blah, blah. So it's the same calculation, but now it's in a separate method. And so now int random index, I want it to be this dot choose index. So now the idea is the color is going to be chosen depending upon the choose index method, which is random here in the rainbow bug class. But what we are going to do now is go down into the subclass and change how this method executes. So what we're going to do is override that method. So here I've written the signature for choose index. So that means we are writing our own version of it in Methodical Rainbow Bug. So we are overriding the version of it in Rainbow Bug. And we are going to define choose index as simply return current index. So now when super.act tries to get the index, the choose index method in this class will be called instead of the random one. And I may be getting ahead of myself a little bit. This is a concept called polymorphism, and we will talk about this later in the unit. But the idea here is you can create new methods when you use inheritance and override little pieces of the methods to make everything work together nicely. Let's go make sure this works correctly. Okay. Oh, actually, what we need to do is we need to not just return current index. We need to return current index mod possible colors length, because otherwise it's going to go out of bounds, right? We're going to keep incrementing current index all the time, and then we're going to mod it by the length, which will always make sure that we're in bounds. Also, notice I do hit this and it compiles. Possible colors is an instance variable up in Rainbow Bug. Usually that is impossible to access, but because we defined possible colors to be protected, and this class is a subclass of Rainbow Bug, we can access it directly. Okay, so this class compiles. Now notice I changed our bug runner while you were sleeping, and I'm creating my own array of colors here. It just is red, blue, green. And I'm passing that colors array into the constructor of the Methodical Rainbow Bug, which I'm creating and adding into world. Now, if this works correctly, the color of the Methodical Rainbow Bug should constantly go red, blue, green, red, blue, green, red, blue, green over and over and over again. Hopefully we got this to work. Red, blue, green, red, blue, red, blue. No, it's not working. Okay, so something went wrong here. Okay, so I think I figured it out. What I forgot to do, up here in Rainbow Bug, I've got choose index here, which is randomly choosing an index, but then I'm also swapping the colors into the 0 index, so it wasn't going red, green, blue, red, blue, green, whatever it was supposed to do. So in order to figure this out, what I'm going to do is I'm going to put the swapping code in the choose index method so that we override it in the subclass, because I don't want to be swapping in the other class. So again, what I'm doing is the choose index, I'm picking a random value to swap into the 0 index, and now I'm always going to return 0, and so 0 is the location of my chosen color at this point. And so I always return 0, and I'm going to set the color to be that color. Now, when I come into the Methodical Rainbow method and I override all that nonsense that's up in Rainbow Bug, no swapping is going to occur. So for Methodical Rainbow Bug, the order of the original array should stay intact the entire time. So if I come back here and I have red, blue, green, red, blue, green, hopefully that's going to be the behavior that we'll see now. Red, well, I can fix that. Blue, green, red, blue, green, red, blue, green, red, blue, green, so on and so forth. So it is working. The reason it's not working right here at the beginning is because of my constructor. The default value for the default color for an ordinary bug is red, and so that's being set right away. One way that we could fix that is to simply put the current index plus plus before super.act, and that would make sure that the very first value was red, and so that we changed right away. So now it's red, blue, green, red, blue, green, red, blue, green. So now we're getting the behavior that we want. Again, the most important concept here is just this idea of inheritance overriding methods where the behavior, where you want to change the behavior in the superclass, and sometimes it means reorganizing your code. When you write a class, like we wrote Rainbow Bug, it's a good idea to break your code out into lots of little tiny methods so that subclasses can override those little tiny behaviors, right? We took out all this code out of the act method and put it into the choosEndex method so that we could override it later in a subclass. And that's good object-oriented design.